Let's solve this question. Majority element. We are given an array of size n and we need to return the majority element. Majority element is the element that appears more than the size divided by 2 times. Okay, you can assume that majority element always exists in the array. N is equal to nums dot length. N is always there. 1 to this. Could you solve this in linear time and O of n space, O of 1 space? Let's first solve this in with the int max times would be nums dot length divided by 2 hash map would be integer map is equal to new hash map for each int in nums map dot put I map dot get or default 0 I comma 0 plus 1 if map dot get I is equal to max times return I. Else return -1. This would not be triggered. We'll get something out of this value. Let's dry run and see. We are given 3. 3 divided by 2 is 1.5. It would be 1. So this would be greater than or equal to max times. More than this time. So divide by equal to will not be there. So map dot get max times 3 2 3. We put it here 3 map dot get or default get the default value would be there. It would be 3. Then 2 would be again 3 is one time, 2 is one time. Then 3 is checked. Again map dot get would be 1 1 plus 1 2. This is present. If map dot get 3 is greater than the max number of times, then it returns I. Let's check it in this manner. If 2 2 3 3 3 2 2, what will happen in this case is we are checking the condition inside while putting all the elements. So it can happen is map in map dot values. We need to return the value 3 or 2. So here we are returning the number of times it is present. For I in map.keys, if map.get I.value, then it would be equal to return this. Why did I take it out of the this for loop is, see in this example, what is happening is 2 is 1 is 1 time, 2 is now 2 times first. Now max dot value would be 1, 2, 3, 4, 5, 6, 7. 7 divided by 2, 3.5, 3 would be the case. This will return us 1 even before the other values are put inside the hash map. Because we are iterating, 3 is the value for no, 3 will not be returned because it is not greater than, we can safely assume that. Let's run and see. Yeah, the open test cases pass because I was thinking if this value is present, 3 is there, so it will return as 3, but the condition is it appears more than n by 2 times. So, and we have checked it, it should be greater than, strictly greater than max times and not greater than equal to. Last, just before that I have put greater than equal to, so I was getting confused in this. Now this is 3, but when we are putting the values, this is not this will be present, but once it is greater than the max number of times, this will return us the output, which is 2, which is the number present. Let's submit and see. Yeah, this works for the closed test cases as well. Okay. The time complexity for this would be, we are iterating through all of them, so O of n time would be O of n, and the space complexity would be O of unique values, unique numbers in array, because we are using a hash map. Now follow up is, could you solve the problem in linear time? And O of n's, O of 1 space, linear time. Linear time is O of n, so that is there. how will we solve this in of one space? We need to find the element whose count is more than the max number of times which is present. And we need not store this. So, because this will give us O of m, where m is the unique number of characters. We need to solve this in log of time. Complexity can be linear, so it is log of n, so we can use for loops, but the space complexity is not, it's linear. Let's try to use a couple of int number would be integer dot max value, int count would be equal to 0. For int I in numbers, if count is equal to 0, number is equal to I. If number is equal to I, then we'll increment the counter, else count minus minus. So the logic behind this is this is just arbitrary value, and we are maintaining a count. What happens is we will after this we'll return the number. Right now we are at 2. Let's take this example first. Right now we are at 3. The count is 0. So number is initialized with 3. If number is equal to the one which we are at, so count will be +1, so this is 1 now, else is not checked. We are at the we are at 2 now, I is 2. Count is the count 0? No. Number is equal to I? No. Number is 3, while the I value is 2, so count minus minus, it will be 0. We come back, I is equal to 3 again. Is the count 0? Yes, it is. Number will be initialized to 3. If number is equal to I, which is yes in this case, so we'll just increment it, and there are no more cases to go, so we'll return number 3. So in this manner we are able to check for all the cases in without using any additional space, because these are variables and this is the space that was provided to us, and the time complexity for this would be O of n, while the space is constant. We are not using any additional space. Let's run it and see. Check it with the open test cases. Let's submit and see. Yeah, this works. This was a good question. Thank you.